Good day everyone, this is Ian L. Palalios, and for today's video I'm going to explain the quiz on our microprocessor, which is the addressing modes quiz, and I will explain my answers one by one on every exercises. So let's go for exercise number one. Number one is move AX comma BX. So my answer is register addressing. So the AX and BX are both CPU registers. That's why it's register addressing. Number two, MOV AX comma open and close parentheses of 1234H. So this is clearly direct addressing because 1234H means it's a memory address. So the CPU goes to memory location 1234H and loads the value into AX. Number three, move AL, comma, open and close parentheses, SI. So SI is a register that contains the memory address. The CPU reads the value stored at the address and loads that into the AL. So my answer is register indirect. Number four, MOV, open and close parentheses of BP plus DI, comma, AX. So my answer on this is base index addressing. It's like base plus index registers. So BP plus DI is a combination of two registers, of course, that form a memory address that CPU stores AX at the address calculated by BP plus DI. Number 5, MOV CX, comma, open and close parentheses of BX plus SI plus 08H. My answer on this is base index, but base index with displacement. So BX plus SI plus 08H is are the address in memory. Base plus index and displacement. So the CPU reads memory from that address into the CX. Number 6, MOV, open and close parenthesis DI, comma AX. My answer in this is register indirect. So the DI contains the memory address, but the CPU stores AX at the memory address inside the DI. So that's why it's register indirect. So number 7, MOV AX, comma, open and close parenthesis BP minus 10H. So the BP is used as the base minus the 10H displacement. So it loads AX from memory at the computer address. So it's based. My answer is based with displacement. Base plus displacement addressing. Number 8, MOV AX, comma, 5678H. So the 5678H is I think directly written directly in the question or instruction. So AX is loaded directly with this value. So immediate, and my answer is immediate addressing. And lastly, number 9 from our exercise 1, MOV AX, comma, open and close parentheses BX. So this BX that has parentheses contains a memory address. So the CPU reads the value at that address into the AX. So the type of addressing mode is register indirect addressing. So for exercise 2, write code for a specific addressing modes. I mean, Number one is immediate addressing. Store the value 0x55AA into the AX register. So my answer is MOV AX, comma 55AAH, because AX is loaded with a constant value written directly in the instruction. So that's it. Number two, my answer is MOV AX, comma BX. I mean the question first, register addressing. Copy the contents of BX into AX. So my answer is MOV AX, comma BX. So it copies the value from BX into AX, like the first one. Number three, direct addressing. Move the value stored at memory location 1234H into AX. So my answer is MOVAX, comma 1234H with the parenthesis because it's direct. So the CPU retrieves data stored at memory location 1234H with parenthesis. Number four, register indirect addressing. Access the memory location pointed to by source point or SI and store its value in AX. So my answer is MOVAX, comma, open and close parentheses of TI. So the AX gets the value from the memory address stored in the SI, of course, with the parentheses. That's why it's register but indirect addressing. Number five, indexed addressing. So it has some combination into this. Retrieve a value. So the question is retrieve a value from the memory address pointed by the sum of DI and the displacement of 10H and store it in AL. So my answer is MOV. Store it in AL. MOV AL, comma, with a close parenthesis of D DI and 10H, DI plus 10H. So that's my answer on number 5. Number 6, base indexed addressing. The question is access memory using the sum of BX and SI and move into the value and move the value into AX. So my answer is MOV, move the value into the AX. So MOVAX, comma, the sum of BX and SI. So open and close parenthesis of BX plus SI. That's my answer on number 6. So let's go to the exercise number 3, address calculation. So the instruction is given the base address 1000H or 1000H, segment address of 2000H, and a displacement of 0010H. So for our number 1 on this exercise 3, under exercise 3, compute the physical address for the instruction MOVAX minus 1000H with the open close and parentheses in direct addressing mode. So my answer, let's discuss the solution, my solution. So it's MOVAX, comma 1000 with the open and close parentheses of 1000H, right? So the on the given the base address is 1000H. This means that the segment is equals, I mean, the offset is equals to 1000H, which is the base address. And the segment is equals to 2000 H, right? So let's calculate the physical address of from let's calculate the physical address on the number one on number one. So segment times displacement plus the offset. So 2000h times 10h plus 1000h. So let's calculate the 2000 times 10 first. So the answer is 20,000 H plus 1,000 H. And my final answer is 21,000 H. That's my final answer on number one. Number two, compute the physical address for MOVAX, comma, open and close parenthesis of BX plus SI plus 10H with BX with BX of 1234H and SI of 4321H. So let's go to the number two. MOVAX, comma to BX plus SI plus 10H. So the BX is 1234H, the SI is 4321H, and the displacement on the given is 10H. So, so the offset, we need to calculate the offset first. Let's calculate the offset with this BX plus SI plus displacement. So 1234H plus 4321H plus 10H equals to 5565H. Now the physical address 2000H, which is the segment address, times 10H, which is the displacement, plus 5565H, which is the answer earlier, which is my answer earlier, or the offset. So let's calculate the 2000H times 10H first. So the answer is 20,000H plus 5565H. And my final answer is 25565H. That's it. Let's go to exercise number 4. Oh, this exercise is a bit hard. Not a bit hard, but not a bit hard. It's hard, especially the number 2. So let's start with exercise 4. Debug and analyze. Analyze the following code snippet and answer the questions. So there are 4 givens. MOVAX, comma, open close parenthesis SI, MOVSI, comma, 2000H, add AX, comma, open and close parenthesis of SI plus 10H, and MOV, open and close parenthesis DI, comma, AX. So for the number 1, identify the addressing modes used in each instructions. So addressing modes used for these 4. So first one is the MOVAX, open and close parenthesis SI, is register indirect. AX gets value from the address inside SI. Number 2, the second one is MOVSI 2000H. It's immediate because it has no parenthesis. So SI is loaded with the constant of 2000H. Add AX. The third one is add AX, comma, with the close and with the open and close parenthesis of SI plus 10H. So this is index. I think it's index with SI plus displacement. because it has Si plus 10H. So it reads from memory at Si plus 10H. So the fourth one, MOV with an open and close parenthesis of DI, comma AX. So still it's register indirect. It stores AX into memory address stored in DI. Let's go to the second one, the hardest one for me, because I mean I don't I don't know uh, I don't know all of it yet, so I need to learn first, then understand why what are these. So the number two is hard for me. I try to explain it. So if the value of number two, if the value of memory location 2000H is 1234 and at 2000H plus 10H is 5678H, what will be the final value of AX? So let's start with the given. There are two memories. So memory of 2000H is equals to 1234H, and the memory of 2010 2000 plus 10H, which is 2010H, is equals to 5678H. So let's start with the first step, with our first step. So MOVAX. So I think I put the X there, which is unknown, because the value at memory address of all SI is unknown. I don't know what's the value of that. So it's AX equals X. And the second one, MOVSI, comma 2000H. SI didn't change, still has the 2000H value. So at this point, it's AX equals to X and SI is equals to 2000H, because yeah, SI gets the value of 2000H. The third one, add AX, comma, open and close parenthesis of SI plus 10H. So we need to calculate the SI and 10H first. So the our SI, right, is 2000H, right, and plus 10H. So it's equals to 2010 or 2010H. And our memory, what is our memory? Second memory, memory open and close parenthesis of 2010H is equals to 5678H. Right? Yeah, yeah, it's on the given. So AX is equals to X plus 5678H. So for the fourth one, the last one, MOV open and close parenthesis DI, comma AX, still didn't change, still given. So the AX is equals to X plus 5678H. Yeah, that's my final answer. I mean, my final answer is final AX is equals to X plus 567H. 5678H. I hope you understand that. I hope you understand my explanation, because it's hard for me to what do we call that, elaborate. I know my answers, but it's hard for me to elaborate in words. In I mean, elaborate to context. Context. So for the last one, I think it's one of the easiest one, which is the exercise 5, aside from exercise 1, number 1. So, number 1 is, it has the instruction. Loads the value 0x ABCD into the memory location of 3000H. So my answer is MOV, open and close parenthesis of 3000H, comma 0 ABCD H. Yeah, because the value, which is the 0x ABCD or 0 ABCD with H, into the memory location of 3000H. So I have to put parenthesis on 3000H because it's a memory location, and after the comma I have to put the 0 ABCDH there because it's the value, right? It stores ABCD at memory address 3000H. Number 2, retrieves this value using direct addressing mode and stores it in AX. So my answer is MOVAX, comma, open and close parenthesis of 3000H. So why is this? So the 3000H with the parentheses, chips using like in AX, right? So the 3000H is the memory location. So it loads the value from 3000H into AX. So yeah, it's direct. I where did I get 3000? Where did I get 3000H? I just assume that it's 3000H because it's necessary for direct addressing mode. We need the exact value. Number 3, copies the value from AX to BX using register addressing mode again, but this time it has no I'm specific value. So my answer is MOVBX is MOVBX comma AX. So copy AX to BX. Register addressing. Number 4, MOV, open and close parenthesis of I MOV with an open and close parenthesis of DI comma BX. So it's indirect because the DI has no specific value. I mean, I'm just assuming it has a value. I mean, it does have a value, but I don't know what's exactly the value. So yeah, it's indirect addressing mode. See, right? Assuming. So we store BX to memory pointed by DI, which we are assuming the value of DI is equals to 4000H. I hope you understand my explanation, sir. I'm not, I'm not good at explanation, but I tried. I mean, it's hard for me to explain and be articulate, but I'm still trying and trying practice. So I hope you all watching, including you, sir, for this video about explaining my answers on the addressing modes quiz. Thanks for watching.